Hey guys, Matheus Castelo here. I'm back to the channel after some time, right? A long time, but yeah, I'm back today to show you some integrations that we have between IDE, Torizon IDE extension for Visual Studio Code and Qt projects, right? So if you want to know more, stay with me. Okay, so let's go to the Visual Studio Code, right? I already have here the Torizon IDE extension for Visual Studio Code installed, right? And when you have it installed, you have now these two buttons here. Let's create a new Torizon project. This will activate the extension and show the multiple templates that we have, so we can create projects based on these templates, right? But today for this video, I am interested on this one, the C Qt 6 QML application. So let's create a new project, right? So this project will be called video show. All right, so also the container name video-show, and I will create it on my home. Okay. Alright, the Visual Studio Code integration, you create the project for me. Okay, so I think that, yeah, when you create a project, this opens automatically for me the specific documentation for this template. Alright, cool. Also, there is an automation here. You can see that asks for me to check the dependencies that I need to have installed here on my operating system. So yeah, let's run this check dependence script. Okay, so my operating system have all the packages that is needed. All right, so yeah, let's go directly to the code. So here on the template, we have a QML folder that stores the QML stuff. So I have my scene, I have the main QML. You can see that there is also QML code, better saying, it's QML syntax highlighting and also some helping, right? So for example, here I can see all the on events, right, for this QML. So everything is already configured on this template, right? You don't need to mess up with the extensions. This has the recommendations and all the settings that is needed to you have everything working. All right, but what I want to show is the automation that creates the project, builds the project, and cross-compile it for an embedded device at target, right? So here on the IDE and Torizon IDE extension, we have this activity bar here that's called the Torizon, and here you can connect new devices. You can scan your network for devices. You can see here that I have a verdin IMX8 and Plus already connected, already set as default. Let's set the default again. You can see that this automatically set the context of Visual Studio Code Docker extension to the remote target. Let me show to you guys here my bank. So I have here the verdin IMX N Plus here, right? It's connected on my local network and also connected to the HDMI reverdi screen. Okay. So yeah, so this is my remote target, right? My embedded device that I will deploy the application. So it's very simple. Let me show you. First, yeah, let's open source code, and yeah, this is the hello world. And let me put a breakpoint here. So when I build it and deploy it on the remote target, you also remote debug it, right? So all this integration is made by the extension, so I can select here which target I want to remote deploy and remote attach to the debugger. So is a Torizon ARM v8, right? So don't worry if you choose, for example, IMD64 here, but my default device is our ARM v8, right? There is no problem. I can continue here, and the integration also you show to you a warning, and you stop the process because yeah, you have a default device that is ARC64 ARM v8, but you are trying to deploy for IMD64. Okay, so let's choose the right one, and okay. So now the integration will build everything for you. Okay, you package this application inside a container without dependencies, everything, and then deploy it on the remote device, right? My verdin IMX8 M Plus that I have here on my back. Everything automatically, okay? And at the end of this deploy, we should have the remote debugger attach it to the Visual Studio Code, and then I can step-by-step debug using the Visual Studio Code. Let's wait. Okay, so now the application you start. You can see that now we have our breakpoint reached, right? So this is already running on the remote target. So when we set the device as default, right? We set the device here as default. This uses now the context, the Docker context of the remote device. So you can see that now we have two new containers running. One is our application and another one is the Weston Wayland compositor. So you can see that the application is already running on the remote target, right? You can see that, yeah, I can show here that the Weston is already running here, but soon we will have also the application, right? So let's go step by step here. I can press F10 in each of this, right? I can check for, yeah, you can see here that this is one of annoying things about the Visual Studio Code, right? The Visual Studio Code does not have all the parser, let's say, that the Qt Creator have for their Qt object, right? You can see that the Q URL, right? This one here, he was able to solve, right, for a string, but the app and the engine, I don't have more actions here. It's only an object with 3 dots, nothing more. Okay, but yeah, this is some limitations when you use Qt projects, when you debug, right, Qt projects with Visual Studio Code. But yeah, let me continue here, and you can see that the application started here on the device. Okay, this is cool already, right? Have all this integration on Visual Studio Code that cross-compile, package everything in one container, remote deploy, remote debug, and everything, right? It's very cool. There are some limitations, as I said, about to solve the Qt objects, but there is also other integrations that we add to this template, to this Qt project, that you can use. Then you can solve this. So use the Visual Studio Code to handle the project and start the Qt, and then use the Qt Creator to debug it. So let me show you. Let me back here to the Visual Studio Code. Let me stop the application. Here on the Explorer, there is this section here called task runner, and on task runner we have some tasks, automated tasks, right, to make easy to you some things for this specific project. And then you can see that there is this start GDB server tasks. Okay, so what this will do? This will do all the automated tasks that the same, right, that we have here when you use the run and debug from Visual Studio Code, but without attach at the end on the Visual Studio Code client, right? So this will start the GDB server, you wait GDB client to attach to the GDB server. All right, so let's run here the start GDB server remote ARM64. So this will cross compile, package everything, remote deploy on our verdin IMX8 and plus, and wait. Okay, the GDB server will wait, so we can use the Qt Creator to attach to this GDB server running on our remote target. Okay, starting, you can see that, yeah, at the end our GDB server is listening and waiting to a GDB client to attach. So now there is some configurations that you have to make on Qt Creator side to have it, right? So we already have an automation here that make it more easy. That is the open in Qt Creator debug, right? So let's run this one. Open in Qt Creator debug ARM64, because this you open the Qt Creator with some configurations already done to you, right? Let me show. Yeah, this needs to build some things to have the context and symbols. All right, and then I should have, yeah, the Qt Creator here. Okay, unfortunately the Qt Creator, I don't know how to make it bigger like we have on the Visual Studio Code, the Control Plus here, and it makes everything bigger. But on Qt Creator, I don't know how to do it, but let me show you. Here is the first time that you open the project on the Qt Creator. It asks you to select or import the kit that you are using. So the Visual Studio Code task already built a folder that is called build local. Okay, so this is the option that should be selected, and you can see that is already selected, the debug here, build local. Okay, so I can then press the button configure project, and yeah, the Qt Creator, you load the project with the same kit that we are using to build our project for the remote target. Okay, so load it, and then let's open here the main CPP. Right here, here I can control and then scroll the wheel of the mouse, and this will make the source code bigger. This is cool. Okay, so what I can do now is put some breakpoint here. Let's put a breakpoint here. Okay, and then start the debug. Right, start the debugging. You can see here debug, start debugging, and there is attached to running debug server. Let me see if I can do it bigger. No, I can't, because this lost the mouse context. Yeah. Okay, but there is a shortcut here that is Alt F5. So Alt F5, yeah, and opens this screen here. So what the automation from the Visual Studio Code task runs to us is to fill these settings here. Okay, so you can see that I already have the kit selected, the GDB multi-arc GDB client. I already have the local executable that is from our build arm64 folder, compiled for our target, and also the working directory that should be the same from the build arm64. Okay. Also, it already selects or sets for us the server channel, right? So this will put the remote IP address and the port that our GDB server is expecting to attach. And you simply click OK, and this will try to attach to our debugger. Let's see here. Some breakpoints cannot blah 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 affected. Okay, select OK, and this will continue for us. You can see that there is some logging here, and you can see that is now already we already have this first breakpoint, the starting of the program here at reached. And let me change here to the screen, right? So you can see that the application you start. If I go ahead, press F10, this will go to the QML application engine, and I can F10 again, okay? And this will kind of, let's say, stop, right? It's like, what's happening? The application stopped, the application crashed, something? No. You can see here, I can back to the Visual Studio Code. You can see that our GDB server is still running. What is Qt Creator wanting here is to also attach to the QML debugger, right? So together with the GDB server, the automation of the Visual Studio Code also spin up a QML port, right? So this is also waiting for the QML debugger now. Very simple. Also, you can go here on debug, start debugging, and then attach to QML port. Alt F6. Okay, Alt F6. Okay, and is already configured with the port that the QML debugger is expecting to attach. Okay, the Visual Studio Code integration, the automation already fill these fields for us. So it's simple. Click OK, and then our QML, again, the debugger, Qt Creator, blah blah blah. Let me back to the screen. So, okay, yeah, you can see that now our breakpoint here reached. So we are attached now to the GDB server and the QML server. You can see here that we have these two options for QML and GDB, right? And then I can go ahead and the application you run. So it's very simple, very cool, and very useful if you want to have a better debug experience with the Torizon IDE extension, right? So let me run again here. I can stop everything. This will stop the application. Okay, you can see the application was done. Let me close everything here and open again. Start again or GDB server. Okay, let's do everything again. The first time takes a bit more time, right? But after that is very quick. Okay, so right, building, loading, starting, and executing. All right, we have the GDB server running and the QML debugger also running. So let's open in Qt Creator debug arm. Because I show all the automation, but do not show to you guys the Qt objects being resolved, right? So let's back here to or man C++ and Alt F5. Okay, because is everything okay? My Visual Studio integration should fill everything with the right data. Now is waiting for Alt F6. I can then attach and click OK to attach to the QML debugger. All right, and now you can see here that, yeah, it's a shame that I can't make the screen bigger to you guys, but you can see here. Let me see. Yeah, you can see here that the engine now solves to a QML application join, right? And then I can go through the object, right? The properties, children properties, methods, and blah blah blah. Everything that we use or are used to from the Qt Creator, right? All right, so let me stop here because I want to show another cool stuff. Because yeah, on the Visual Studio Code we can also open QML files, right? There is some help in here from the QML language server, okay? But for designing the stuff, the designer here is much more cool, right? From the Qt Creator. So this is possible also to you open here, do everything that you want to do on the designing of your QML application, and then use the Visual Studio Code to remote deploy and remote debug your application using the Torizon IDE Visual Studio Code extension. Okay, so I think that yeah, I think that's it. Thank you a lot to stay with me until now, and yeah, let me know if you liked this kind of content, if you liked this integration between the Visual Studio Code Torizon IDE extension and Qt projects and Qt Creator. Let me know if this will be useful for you. So that's it. See you on the next video.